Okay, so we're recording. And here's 2018 number 2. So you can see they give you a velocity function. And it's really weird, you know. It's got like sine and like polynomial function on the denominator is from 0 to 3.5. They give you the initial position. They tell you initially the particle's at -5 when t equals 0. So here they're asking for the acceleration at t equals 3. Now, in case you forgot, the derivative of velocity gets you acceleration. So acceleration is simply the derivative of velocity. And we're going to want to evaluate this at 3, just so you know. So what I need to do, I'm not going to do this derivative by hand. That's insane. And remember, it's a calculator section. So let's actually put it into the calculator. So I'm going to pull up my calculator. Clear all the junk I have here. Clear this junk. And I'm going to type it in. So, and you could actually type it as a fraction. You could alpha y equals. You could actually type it in like a fraction like this. So, or you could do parentheses in the numerator, then divided, then parentheses for the denominator. That's fine too. So 10 sine 0.4x squared, 0.4x squared. And next up is x squared minus x plus 3. Okay, so I've entered. I'll go ahead and quit out to the home screen. And you want to do a derivative alpha window, option 3, dx, and alpha trace y1. That's what you call y1. And it's good to store from the get-go, from the beginning, to store whatever equation you see for the first response questions where a calculator is required, numbers 1 and 2 of the first response. Whatever equation you're given, store it right away as y1, because you're going to have to use it often for all the other parts. And then, of course, you're evaluating this at x equals 3. Okay, I get -2.118. There we go, done. And they didn't give us units here, so don't worry about the units. But remember, you got to round to at least 3 decimal places. So you could write that whole thing as you see, that's fine. Or you do -1.118. But if you put -0.12, -2.1, or just -2, if you round it too soon, you would not get the point for the answer, unfortunately. And let me show you the answer key really quickly. Yeah, it was just 1 point. So if you didn't round correctly, you got nothing. So that one part was worth just 1 point. And remember, the first response was worth 9 points, and they divvy up those 9 points among all the parts. Okay. Next up. Now find the position of the particle. Now that's something that I don't think my deep period students would quite know how to do just yet, but I think they can kind of make sense of it a little bit. So you got to do the antiderivative of velocity to get to the position function. The antiderivative is the definite integral. And I know I've talked about definite integrals with the deep period students, but we haven't quite got into the fundamental theorem of calculus, which we'll do next week. So find the position of the particle at t equals 3. So what you're going to do is the integral, and we'll do it from 0 to 3, of your velocity function is going to equal the change in position, or the displacement, s to 3 minus s to 0. Well, s to 3 is what we want to find. I want to find the position at 3. S to 0, you're told the initial position is -5. So we'll do minus -5, actually. And then you got to work out this integral. 0 to 3 of all that junk, which I don't feel like writing, dt. And you got to use your calculator to do it. So what I'll do, so s of 3, the position at t equals 3, will be -5, because I got to move the 5 from right to left. So -5 plus the integral from 0 to 3 of all that junk, dt, right? Okie dokie. So I am going to go back to my calculator. I already have it stored. And actually, let me clear this other stuff here. There we go. So you can see a little better. So I already stored. So just go alpha window, option 4, 0 to 3 of alpha trace y1 dx. There we go. And then what I need to do is just do -5 plus that. Add that to -5. That's your answer, -1.767. So remember, when you're going from velocity position, you have to do the antiderivative, which is a definite integral. And that'll be, trust me, for the DPA students, they'll be very clear by Monday or Tuesday, just so you know. And if we look at the answer key, yep. You have to give you a point for writing the integral, a point for using the initial condition -5, and a point for the actual answer. So that's worth 3 points. So those aren't too bad. Okay, now part C. They're asking you to evaluate the integral from 0 to 3.5 of your velocity, which actually we just, the 3.5, we did from 0 to 3, got it. And then also evaluate the same integral but do the absolute value velocity and interpret the meaning of each of those integrals in the context of this problem. Okay, well, go back to your calculator, alpha, window, 0, 3.5, alpha trace, or I could have actually repeated the second previous entry, that's fine. Okay, I get that. We repeat it. Well, the absolute value, so alpha window, absolute value is right there. Alpha trace, y1. Takes a little while to get that. So interesting, we get 2 different answers, right? Now, what do those mean? We do the integral of velocity, that's going to be displacement, just so you know. We do the integral of the absolute value, that's going to be total distance. So remember, displacement is the change in the total distance. Like if you were to walk, if I walk from one end of the house to the other, and the back, my position would be 0 because I'm back to where I started from. But I actually burned some calories. I took some steps. That'd be total distance. You probably also want to say the time interval too. So like 2.844 is a displacement for the timer from 0 to 3.5, whereas the absolute value, the integral of that, is the total distance, 3.737. The total distance traveled during that time interval from 0 to 3.5. So to give you a point just for getting the answers, so combine both of those is worth just 1 point. And then they give you a point for each interpretation, doing each interpretation correctly. Okay, then we'll do, excuse me, part D. Now for part D, you have a second particle. It moves with that position, so the position function. You want to know what time are they both moving the same velocity. So you need to get the velocity function from the position function. Well, that's easy. That's just doing a derivative. You guys should totally know that. They use X for position. I like using S. Doesn't matter. That's going to be 2t minus 1. Now, I want to see when that position is the same. Sorry, when that velocity is the same as that velocity. I want those velocities to be the same. I want to know what time those velocities are the same. So 2x minus 1. Okay. And I'll probably, I don't know, they say from 0 to 3.5, so let me change to 3.5. And I don't know if I want to go that high. Maybe 10 is sufficient from y max. If I don't see intersect, I'll adjust it. Again, make sure you're in radian mode. Okay, so intersect right there. Second trace, option 5. 1, 2, 3. There we go. I get 1.571 or 1.570. So to give you a point for knowing the signals equal to each other and a point for giving the answer. So again, not too bad. Okay. So questions about 2018 number 2? Nope. All right. So let's go and try 2019 number 2. It might seem a little difficult at first, but it's same kind of situation. So it's linear motion. I'll go ahead and stop the recording as well.